For number 55, we have this decimal expansion here, 1.5342 repeating, and we've broken this down into two parts. That's 1.53 that's fixed, and the expanding part 0.00424242, and so on. And so we want to express this number as a ratio of integers, so as a fraction. And what we're going to do here is we're going to take this expanding part and we're just going to express it as an infinite sum. So we can say that that's the same thing as 0.0042 plus 0. And then we're going to put zeros before and then another 42 plus 0. Put zeros beforehand, and that's another 42, and so on and so forth. Because if we sum this up, we can see that that's going to give us 0.00424242, which is what we want. So let's take these decimal points and just express them in terms of powers. So for this first one, that's just going to be 42 times 10 to the minus 4, since we have 4 decimal places. The next one would be 42 times, and we have 6 decimal places, so that's 10 to the minus 6. The next one we're going to have 42, that's going to be times 10 to the minus 8. And so the pattern here is very clear that these are the even numbers, but beginning at 4. So the next one would be 42 times 10 to the minus 10, and so on and so forth. But this is going to be a little bit difficult for us to express in terms of our series. So what I'm just going to do is I'm going to make it begin at minus 2 in the powers. So that's going to be 0.42 times 10 to the minus 2. So that's the same. And this is going to be 0.42 times 10 to the minus 4. And so this one's going to be 0.42 times 10 to the minus 6. The next one would be 0.42 times 10 to the minus 8. And once we've expressed this way, we can see that this whole thing ends up being the infinite sum from n is equal to 1 to infinity of 0.42 times 10 to the minus 2n. And that's the reason why I chose to reduce the power to minus 2, just because it would be much better with n is equal to 1 in the index. So if we plug in n is equal to 1, that's going to give us 10 to the minus 2 times 1, which is minus 2. For n is equal to 2, that's going to be 10 to the minus 2 times 2, which is minus 4, so that is there. For 3, 10 to the minus 2 times 3, so 10 to the minus 6. So we can see here that this index works perfectly. So we can now expand this into saying that's just going to be 1.53 plus the sum from 1 to infinity of 0.42 times 10 to the minus 2n. And we just want to simplify this 10 to the minus 2n. So 10 to the minus 2n, we can say that 10 to the minus 2 times n, we can say that's 10 to the minus 2 to the power of n, which is the same thing as 1 over 100 to the power of n. So we're just going to simplify this as 1 over 100 to the power of n, because that's going to be easier for us to calculate the sum. So that's going to be 0.42 times 1 over 100 to the power of n. So once we're here, we're almost good to go. Now we can look at the formula for a geometric sum. And the formula for a geometric sum, it goes from n is equal to 1 to infinity of ar to the power of n, and that's a sub 1 over 1 minus r, if the absolute value of the ratio is less than 1. So in this case, the ratio, so the thing that's being raised to a power of n, is 1 over 100, so definitely less than 1. So that means that we can use this formula. So in our situation, a sub 1 is the first term. So if I plug in n is equal to 1, I'm going to get 0.42 times 1 over 100 to the power of 1. So that's 0.42 divided by 100. So that's my a sub 1 here. And then all over 1 minus the ratio. So that's going to be 1 minus the ratio, which is 1 over 100. And so if we simplify, that's going to be 0.42 divided by 100 divided by 1 minus 1 over 100. That's going to be 99 over 100. And so the answer is therefore going to be 0.42 divided by 99, because both of them have 100 in the denominator, and that cancels out. So that's going to be 1.53 plus 0.42 divided by 99. And now we just have to put this in our calculator. And that's going to give us, if we put it in our calculator, let's see, it's going to give us 5,063 divided by 3,300. So that is it for this problem. That is the rational expression for this infinite decimal.